We are now going to look at some applications of problems that we've been working on throughout the semester. And so hopefully after today, you're going to be able to translate verbal descriptions into mathematical expressions. You'll be able to solve interest problems, mixture problems, uniform motion problems, and constant rate job problems. So first, let's look at interest problems. So interest problems. So if we're looking at simple interest, then we have the following. So if a principal of P dollars is borrowed for a period of T years at a per annum interest rate R expressed as a decimal, the interest rate I is, okay, so our interest rate that we're earning, which is I, is equal to how much we've invested. So this is our P, the principal, and then times R, which is the interest rate in decimal form, times T, which is our time in years. So suppose that you've borrowed $1,000 for 6 months at an interest rate of 6% per annum. What is the interest that will be charged on this loan? Okay, so we're trying to find our interest, I. This is equal to the amount that we've borrowed, or invested, in this case, for borrowed. So this is our P value. So P is 1,000 times our interest rate R. Our interest rate, though, needs to be in decimal form. So 6% divided by 100 to put it in decimal form, which is 0.06. Times the time that we are investing. And this is for 6 months. Well, it told us that our time is in terms of years. So 6 months, this is equal to a half of a year. So this is what our T value is, 1/2 or 0.05, whatever way you want to write it. And so now we're just going to go through and multiply across. I noticed that a half actually goes into 1,500 times, so I'm going to simplify first. Times our interest rate of 0.06. And so I get my interest rate on what I borrowed is 500 times 0.06. So I'm going to kind of do this without a calculator because I don't have one in front of me right now. So 6 times 5 is 30. I'm going to carry the 2 zeros from the 500. But then I am multiplying by decimal, which is 2 spots over. So I need to move my decimal over 2 spots, which would put this right here. And so it looks like that the interest from the $1,000 I borrowed for 6 months is $30. So the question next says, if you pay the loan back at the end of the 6 months, what is the amount you paid? Well, the loan, the amount that we're paying back, is equal to the interest that occurred plus the money that we borrowed. So the amount that we're going to owe after 6 months is our $30 plus our $1,000 that we borrowed. So we're going to owe $1,030 if we pay it after 6 months. So we have a next application problem in front of us. So when you're working through word problems, first thing you want to do is you want to read through the problem just to get a feel for it. Then go back and read through it and pull out some information that is given to you. You are going to define what variable you're using and what it stands for. You need to figure out what equations or equations you're using to answer the problem, and then solve and then answer the question. So a lot of times, and if I had this on an exam, I might have 3 little pieces over here. So A, this is where you are defining your unknown. As a variable. Part B, you're going to set up your equations. So I'll set up the equation or equations used to solve. And then part C, answer the question. And with word problems, you usually are going to have some sort of a unit. Okay, so let's go through and let's just read the problem first. So Candy has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe, government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of the money in a non-insured corporate bonds, paying 12%. So how much should she be placed in each investment to achieve her goal? Okay, so she wants 9% back. And she has 70,000 to invest. So we know that the principal here that she's investing is $70,000. She wants a return. So she wants the return to be 9%. She can invest in 2 different accounts. One pays 8%, and the other one pays 12%. So how much should be placed in each investment to reach her goal? Let's go back over here. So she has 2 different accounts that she's going to invest her money. So let's say X is equal to the amount invested in one of the accounts. So let's say X is the amount invested that pays out 8%. Well, we know that she has $70,000 total to invest, and X dollars of that is what she's invested at 8%. And so I know that $70,000 minus the amount that she's invested at 8% would have to be the amount that she's invested at the 12%. Okay, so now we need to figure out how to set up our equation. We know that this is an interest problem, and she wants to get 9% back off of her investment. I'm just going to assume that this is, it doesn't say how many years, so I'm going to assume that this is just for 1 year. So we know that she wants a 9% return. So the interest on here, this is equal to the amount that she's going to invest total. She wants a 9% return on this 70,000 times the interest rate. You want 9% back. So 0.09 times time 1. Okay, so this is how much she wants. So that's one side of the equal sign. So 70,000 times 0.09 times 1. So this is equal to, well, she's going to get 8% on part of her investment. So 8% times the X dollars that she put in there. So X times 0.08 times time, which is 1, plus the interest that she gets back for the 12%. Well, the amount that she's investing at 12% is that $70,000 minus X, the amount that she put in at 8%, times the interest rate. Well, 12% we can write as 0.12 times time. So we now have the equation, and so we can use that to solve. Okay, so we have $70,000 times 0.09. That is going to give us 6,300. Is equal to 0.08x plus, so I need to distribute here this 0.12 to the 70,000 and to the negative x. So 70,000 excuse me, times 0.12 is 8,400 minus distributing that 0.12 to the x, so minus 0.12x. Okay, so we have a linear equation. Let's simplify down the one side by combining like terms, and then we want variables to one side, constants on the other. Okay, so we have 6,300 is equal to, well, here we have a 0.08x minus a 0.12x. So 0.12 minus 0.08 is 0.04, but it's negative. So negative 0.04x plus 8,400. So we want all the terms with the variables on one side, all the terms are constants on the other side. So if we subtracted 8,400 on both sides, so we have 8,400, they're opposite signs, so subtract minus 6,300. And that would give us negative 2,100 is equal to negative 0.04x. So getting x by itself, we can divide by the coefficient in front of x, which is negative 0.04. So negative divided by a negative is a positive. And so when we do this, we get x is equal to 52,500. So go back and look at your question. Does that answer make sense? If we we need to invest $52,500 and we were investing less than that, then that would should send some red flags up. But she's investing $70,000 total. So 52,500, that sounds legitimate to me. And so answering our question, that's how much X was the amount that she invested at 8%. And so she's going to invest $52,500 at the 8% account. And then we need to figure out at 12%. Well, for 12%, we're taking the amount that we invested at the 8% and subtracting that from 70,000. So if I take 70,000 minus that answer, we get back 17,500. So invest. So 17,500 at 12%. So a lot of times it looks kind of overwhelming when you're looking at a word problem, but you just need to go through it, read it, and then go through it slowly. Use information that you know or equations you know from the past and set it up. So the next problem we have in front of us is a mixture problem. You're in charge of a local carnival and need to buy 100 pounds of candy, but have only $300 to spend. If the candies you are interested in are priced at $2.50 per pound and at $3.75 per pound, how many pounds of each can you buy? Okay, so you're in charge. You need to buy 100 pounds of candy. But she only has $300 to spend. We know that there's two different types of candies that she's looking at. One of them is priced at $2.50 per pound, and one is $3.75 per pound. The question we're trying to answer is how many pounds of each kind? So we're going to let our variable be one of the kinds. So let maybe X equal the number of pounds of the $2.50 per pound candy. Okay, so that was X pounds, but that is X pounds out of the 100 pounds of candy that she's buying. And so, for instance, if she had 10 pounds at the $2.50 per pound candy, then 10 pounds out of the 100 pounds would give us 90 pounds left. So we need to look at the 100 pounds minus how much she used at the $2.50, how many pounds candy. And that's how much she is going to use or buy. This is the amount. Of pounds for the $3.75 candy. So we want to set up our equation. So cost. So if we have X pounds and it's $2.50 per pound, then we have $2.50 times the number of pounds. So that's how much she's paying just for the $2.50 per pound of candy. Plus, so the cost of the other one, which is $3.75, times the amount she's buying. So she's buying 100 minus X pounds of that type of candy. So the cost of one plus the cost of the other should equal how much she has to spend, which is $300. So we've set up the equation that's going to help us figure out how much of each type of candy she needs to buy. So first thing we want to do is simplify down the one side of the equation. And so we need to distribute our 3.75 inside the parentheses. So let's bring down the 2.50x plus, so distributing 3.75 times 100, well, that's 375 minus 3.75 times x, so 3.75x is equal to our 300. So combining like terms on the one side. So I have 250x minus 3.75x. So really negative 3.75. So 3.75 minus 2.5. So that's going to give me a negative 1.25x plus our 375 equals 300. We want our variable by itself. So bringing our constant to the other side, we can get rid of the 375 by subtracting 375 on both sides. So we get negative 1.25x is equal to negative 75. So dividing 75 by 1.25, we get back 60. And we're talking about pounds. So answering our question, you're going to buy 60 pounds of the $2.50 candies per pound. And well, we had 100 pounds total. 60 pounds are going to the $2.50 per pound candy. So we would have 100 minus 60, or 40 pounds of the $3.75 per pound candy. So now looking at uniform motion problems. So let me just read through this and then we'll talk about it and look at a problem. So objects that move at a constant velocity are said to have uniform motion. When the average speed of an object is known, it can be interpreted as its constant speed. Uniform motion formula. If an object moves at an average speed or rate, we call that usually R when we're looking at these problems, The distance, we'll cover, use the variable d, covered in time t, is given by the formula distance d is equal to the rate or speed r times time t. So distance equals rate times time. So when we're looking at these types of problems, sometimes we might want to find the rate or the speed that you're going. And so we can use this formula to figure out time or rate. So if we wanted to find out the rate you were going and you were given distance and time, we could divide both sides of this equation by t. So we know that distance is also, rate is also equal to distance over time. Or if I wanted to find time, looking at the original formula, I can get time by itself by dividing both sides by our rate. So time is distance over rate. So these are other forms of the equations that you might see. So in an example of this, Tanya, who is a long distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves your house, you leave in your car and follow at the same rate. If your average speed is 40 miles per hour, how long will it be before you catch up with Tanya? Okay, so let's go through and pick out some information. So we know that her average speed is 8 miles per hour. So let's just look at Tanya. So we know that the distance for Tanya is her rate, which is 8 miles per hour times time, t. But 2 hours after Tanya leaves your house, you leave in your car and follow the same route. Okay, so your distance is equal to your speed. Well, you're going 40 miles per hour. So 40 times time. If t, though, is equal to the time Tanya traveled, or runs, you leave 2 hours after Tanya. So you have t minus 2 is equal to the time it takes to catch up. So my distance is her time minus 2 hours, so t minus 2. Well, if I'm following the same route that she's running, and she and I are both leaving my house, then the distance that we traveled would be the same when we catch up to her in the car. And so I could, for my equation to set up, I'm looking at her distance, which is 8t, equaling my distance, which is 40 times t minus 2. So now I have my equation to help me solve this. So let me just write it out here and solve. So I have 8t is equal to, distributing my 40 inside the parentheses, I have 40t minus 40 times 2, so minus 80. Let's get t by itself. So let's subtract 40t on both sides of the equation. So doing so, we have negative 40t plus 8t, which is negative 32t, is equal to negative 80. So let's divide both sides by negative 32. And so doing so, we get that t is equal to 2.5. How long will it be before you catch up to Tanya, though, is the question. So I know that Tanya ran for 2.5 hours. And I left 2 hours after Tanya started running. And so if I subtract off 2 from 2.5, 2.5 minus 2 equals 0.5 hours. To catch up to Tanya. So half an hour to catch up. So the next problem, we have 2 workers. One worker takes a certain amount of time to do a job. Another worker takes a different amount of time to do the same job. How long will it take them to do a job together? And maybe it's not workers, maybe it is a pump or a hose pumping water into a pool or something. And one hose takes, a certain amount of time to do a job. A different hose that to do the same job takes a certain amount of time, etc. How long together? So to set these types of problems up, if A, let's say capital A, is equal to the amount of time it takes a person or machine to do a job, let capital B equal the time for a different person or machine to do the same job. And C is equal to the time it takes to do the job together. So when we're setting up these types of problems, we're looking at 1 over A plus 1 over B is equal to 1 over C. So 1 over the time it takes one person to do a job plus 1 over B, the time it takes some other person to do the same job, is equal to 1 over C, the time it takes both of them to do the job together. So knowing how to set these types of problems up right now, let's go through the example or word problem in front of us. So it takes John 4 hours to paint a fence. When his friend Tom helps him and the two work together, the fence can be painted in 3 hours. Okay, so I know that together, fence can be painted in 3 hours. So how long will it take Tom to paint the fence by himself? Okay, so let's set this up. So maybe let X equal the time it takes Tom to do the job by himself. So setting up our equation, we have 1 all over the time it takes John to do the job, which was 4 hours, plus the time it would take Tom to do the job by himself. Well, 1 over, we're trying to find that, X, is equal to 1 over the time it takes them to do the job together, which is 3. So we now have the equation to help us solve this. So we have fractions in our equation. We've seen that we can clear our fractions if we have an equation by multiplying everything through by our least common denominator of the fractions within the equation. So looking at 4x and 3, the smallest term that 4x and 3 divide into, our least common denominator, is going to be 12x. So we're going to take our 12x and we're going to multiply 12x on both sides of our equation. So we ended up choosing this so that our denominators would go away. So I have 12x times 1/4. So 4 goes into 12 3 times, so I'm left with a 3x when I distribute 12x to 1/4. 12x times 1 over x, well, that's 12x over x, so that just leaves me with plus 12, is equal to 1/3 times 12x, 3 goes into 12x, 4x times. So let's get x by itself. If I subtract 3x on both sides of my equation, 4x minus 3x is 1x, or just x, is equal to 12. We had chosen x to be the time it takes Tom to do the job alone. And so it will take Tom 12 hours to paint the fence by himself.